Hi, myself Chetan Kumar BV from Bangalore. This is a small demo video for Gate Academy. Before I start out, as I said, let me introduce myself. Myself Chetan Kumar, basically from Bangalore. I have done my engineering in mechanical engineering from Sir MBIT Bangalore. After that, I worked with Quest Global for a year's time, and then I pursued my MTech in thermal engineering from NIT KG, Surathkal. Pursuant to that, I got placed in GE Bangalore, the John F. Welch Technology Centers. I worked there for a year's time, basically on gas turbines. After that, I quit my job to pursue civil services. I have been preparing for civil services for 2 years now. Recently, I've also been teaching as a part-time job to GATE students. I have had 2.5 years of teaching GATE students in mechanical engineering. I've taught at GATE Academy Mysore and GATE Academy Cochin, apart from a small institute called GATE IIT in Bangalore. I have handled subjects like heat and mass transfer, theory of machines, vibrations, basic thermodynamics. Apart from that, I've also handled classes for BTech students. I've given GATE 3 times. All 3 times I've got a rank within the 1000 rank. Um, that's it about me. Now I'll start off with my subject today. This is basically, I've selected second law of thermodynamics, small topic. Um, Given the limitation of time and being a demo video, I'll limit myself to discussing only second law here. Yeah. Now, the second law of thermodynamics is a very important part for GATE. Yeah, you always have a question from this part. So it is very important that you understand what it is and also understand it in the right way. Okay, now why do we have laws? Basically, see, the first law, be the second law, the third law, they all define whether a process in thermodynamics is possible or not, and if it is possible, it tells us the limitations on the process, right? It tells us how the process takes place. See, the first law, as we all know, talks about the conservation of energy. It says that energy can neither be created nor be destroyed, right? But the first law itself won't be sufficient. Let me give you an example. Say, okay, what does the first law say? The first law says energy can neither be created nor be destroyed, right? So it only says that if a process is possible, right? If a process is possible, it tells us under what conditions does the process takes place. See, it says if so according to first law, such a process might be possible. Say for example, you have a metallic rod, okay, a metallic rod which is at a uniform temperature, exposed to room temperature, say 25 degrees Celsius, right? The first law, if suppose say I say a process occurs such that there is no external heat being added, but heat flows from one part to the other part, right? Then we can say that one part gets heated and the other parts gets cooled. There is no external heat flow, right? The first law does not explicitly say this process is not possible, though we know that this is not possible in actual, right? The first law does not say it is not possible. It only says if such a process occurs, then the heat lost by the hotter side will be the heat gained by the colder side. So we can make out that there are some directional limitations of first law, and this is where the second law of thermodynamics comes into play. Right? Uh, See, now why second law? Right? The second law says whether a cyclic process is possible or not. Right? And if it is possible, uh, it says whether it is a reversible process or an irreversible process, right? So second law tells us about the probability. It tells us whether a process is possible or not, and if it is possible, in which way it occurs. And so if a process obeys first law, not necessary that it will occur in actual, but if so, when we check, right, in certain problems, right, they ask if this process is possible. the first thing you should see is if it obeys the second law, then the first law, right? Say now, so you understood the significance of second law, right? See, we know about spontaneous processes, right? See, what are spontaneous process? They occur without any external aid, right? They always occur in one direction. Say for example, water flows from a higher level to a lower level, heat flows from a hotter body to a colder body, and time always flows in the forward directions, right? These process as they are cannot be reversed by themselves. We need to see time. Forget, time can never be brought backward, right? That is the stuff of movies, the time machine and all that. So but heat can flow from a cold body to a hot body. Water can be pumped from the lower floor to the higher floor, provided there is some external work, right? So the second law talks about this. Okay, there are two statements or two second law of thermodynamics. One is the Kelvin Planck statement, and the second is the Clausius statement. I'll deal with both. But before we get there, see, you would be well versed with the Joule's experiment, right? Where we study about Joule's experiment in first law of thermodynamics under a closed system. See, what did Joule's experiment finally establish? It states that W net is equal to Q net. See, what we basically did is we introduced some work into the closed system in the Joule's experiment, and we allowed heat to flow. We observed that W net and Q net were equal, right? So, and we also know that both have shared the same units, but there is a quantitatively there might not be any difference, but there is a qualitative difference between heat and work. See, work is a higher form of energy, heat is a lower form of energy. In Joule's experiment, what was it that we were doing? We said all work was getting converted to heat. Possible, because higher form of energy can be converted to lower form of energy with 100% efficiency, alright? But in a heat engine, now what is a heat engine? A heat engine is a work device which takes in heat energy and gives out work, right? Now see, the input is what? Heat energy, a lower grade of energy. The output, work energy, a higher grade of energy, right? So we are converting lower grade energy to higher grade energy. We cannot expect 100% efficiency. This is the crux of the Kelvin Planck statement, right? It says not 100% of the heat input can be converted to work. Clear? So let's build upon Kelvin Planck statement from this point. So what is the statement of the Kelvin Planck statement? It states that a heat engine, right? A heat engine cannot develop work by interacting with only one heat source, right? So